Okay, another example using the generalized power rule. This is similar to number 8 in the book. They give you this function p, and they ask you to compute the derivative of p. Okay, so what we want here is dp dn. The variable is n instead of x or t or anything else, but that's not a big deal. Okay, so taking the derivative with respect to n of this big function. Okay, now I'm going to go ahead and do two things as I write this derivative. Normally I would just write the original function right here next to the derivative sign. But I'm going to do two things that are important to simplify the problem. First of all, I've got this 0.29 out front, and you can factor constants outside. So when I take the derivative of this big expression with respect to n, I'm going to go ahead and factor out that 0.29. Okay? And what I have left is the square root of one big thing. So remember, that's an important thing we need to do. To use the generalized power rule, we have to write everything as a power. Okay? So I'm going to write this big expression as 0.7n squared plus 7n plus 25 to the power 1/2. Okay? Because I like to have things written as a power. Okay, so I've got this 0.29 I'm going to have to multiply in, but now I just need to use the generalized power rule. So we have some big expression raised to the power 1/2. Okay, I bring down that power, multiply by the exact same thing inside, 0.7n squared plus 7n plus 25 to the power negative 1/2. Okay, it's the old power minus 1. Okay. And then here's the trick. It's the generalized power rule. So we have to multiply by the derivative of what was inside the power. Okay, what was being raised to the power originally. So I'm talking about the derivative of 0.7n squared plus 7n plus 25. Well, that's not too bad by itself. The derivative of the first term is going to be, I think, 1.4n. Derivative of 7n is 7, and the derivative of 25 is 0. Okay, so that's kind of the difficult part here. We've got to piece it all together into one big problem. Okay, so now, and again, I think in this problem they might just ask you to compute the value of the derivative at a couple of numbers, but it doesn't hurt to simplify this a little bit. One thing you might do is go ahead and multiply. You could leave the 2 in the denominator, for example. Okay, and distribute that 0.29 into the numerator. That might be kind of a reasonable thing to do. So let's see here if I can get my calculator handy. So what do I need? I need to take the 0.29 times 1.4. Okay, so let's see what I'm doing here. I'm leaving that 2 in the denominator. I'll bring this down as the power positive 1/2 in the denominator. That's just the square root of 0.7n squared plus 7n plus 25. So you see what I did here? I made the power positive 1/2 by bringing this into the denominator, and then I wrote it as a square root. Okay, so anyway, back on track. I still have the 0.29, and I want to distribute it into the 1.4 and plus 7. So here's what I have left to do. Okay. So yeah, that's what I was trying to type on the calculator here. Well, 0.29 times 1.4 is 0.406. So I've got 0.406n plus, and then I've got 7 times 0.29, which is 2.03. Okay, so that's all over 2 times the square root of 0.7n squared plus 7n plus 25. Okay, and again, if they just want you to put some numbers in for n and crunch this expression, then that's all you have to do. But pay attention to the problem, again, what they're asking for. If they say round it to 2 decimal places, you can do that. If they want an exact fraction, if it turns out you could get a nice fraction on this, that might be what they're looking for. So leave it symbolic. But I think probably on this problem they would say round your answer to 2 decimal places or 3 decimal places. Okay, so that's the derivative, and all we have left to do is put whatever numbers in for n to compute the rate of change of that function.